All right, so welcome to today's lesson. We are going to be looking at logs and exponentials. Okay, so the most important thing when you're looking at logs and exponentials are the laws. Okay, the laws of logs. Okay, and then the most common questions that you're going to be asked to convert from one form to the other. Okay, so meaning you'll be converting from the log form to the exponential, or the exponential form to the log. Okay, so these two are married. They're like husband and wife. They are inseparable, right? Okay, maybe husband and wife are inseparable. So, which ones are not separable? Okay, maybe brothers and sisters, because you always be siblings, right? Yeah, so they are brothers and sisters. All right, so in general, okay, in general, we represent a log function in this form. Okay, we are going to say we have log A, okay, and then B, and then this is going to be equals to Y. Okay, so this is the general form of expressing a log function. Okay, so this one here, the A, the B, and the Y, they have names. Okay, so this A here is what we call as the base of this log. Okay, and then Y, it will be called the answer. Okay, and then this B here, it will be called uh, what is in the middle. So we can just say middle. Okay, because we see it is in the middle between the base and the answer, right? Okay, so base, middle, the answer. So any log that you have will be in this form. Okay, so when you are converting from the log form to the exponential, okay, you actually use a mnemonic that we say base to the power answer is equals to what is in the middle. Okay, or it's simple, you can just say base power answer equals to middle. Okay, so we are moving like this. From the base to the power answer is equals to what is in the middle. Okay, so when we abbreviate that, we get BAM like that. Okay, so we are going to be using this mnemonic BAM to remember, okay, our conversions from logs to the exponents. Okay, so meaning this one, I can write it in exponential form now by following my BAM. Okay, so it will be base to the power answer is equals to what is in the middle. So simply meaning that A, which is the base, to the power answer, which is Y, is equals to what is in the middle, which is what? B. Okay, so we can convert from log to exponentials or exponentials to log using uh, what I've said there. Okay, all right, so that's the formula that we are going to be using, okay, when we want to convert from one form to the other. All right, and then after that, we need to talk about the laws of logarithms. Okay, so there are a number of them. There are about, is it 7 or 6? Okay, but we are going to talk about them. Okay, so let's talk about the laws now of these logs and exponentials, since we've known now how to convert. Or maybe before we do that, we can give an example, right? Okay, let's give an example here. So if, for example, I have log base 10 of 4, okay, is equals to x, I can convert this to an exponential by saying base to the power answer is equals to what is in the middle. So it will be 10, the power x is equals to 4, okay? So that's how we can do it. All right, so let's now look at the laws of the logs. And then after that, we can look at some practical questions that come. Okay, so the first uh, property of logs, okay, the first property of logs is just a very simple one, okay? Simply saying that log of base B or let me use base A. So log of base A, okay, of a sum, of a product, let's say x multiplied by y. This here is the same as log base A of x plus log of base A y. Okay, so whenever you see a sum of two logs and they have the same base there, we can actually combine them into a product. Okay, number two, uh, it's the law that involves division and subtraction. So here we are doing multiplication and addition. This one is division and subtraction. So if I have log A of x over y, this is the same as log A of x minus log A of y. Okay, uh, a very beautiful property. Okay, so we are going to see how useful it is when we are solving questions. Then three, we can look at the power rule, okay, of logs. So simply saying if I have log base A, okay, of let's say number x to the power n, okay, the log allows us, okay, or gives us permission to drop this power in front like that. So this n goes in front like that. So it becomes n log base A x. Okay, so this expression here that you're seeing and this expression here, they are the same. Okay, they are the same. And then number four, we are going to look at the identity log. Okay, so simply saying if I have log of base A and then I have this same base here in front here as the bigger number, then this is just equals to 1. Okay, so as long as I have two similar numbers there, so it can be log base 5, 5, this will be 1. Okay, log 6, 6, this will be 1. Okay, as long as the base and this number that is following, which we called was the number in the middle, right? As long as they are equal, this one here, the base and what is in the middle is equal, then the answer will always be 1 like that. Okay, so why is it that we can see it when we convert this to exponential? So base to the power answer is equals to what is in the middle. So this will be a to the power 1. Definitely should be equals to a. Okay, so that's where we get this property here, a very useful property. And then let's look at, so that was the fourth one, right? Okay, so we can look at the fifth one. Okay, the one that gives um, okay, the one that gives is it a 0 or something like that? Okay, so I can say the fifth one is when I have okay, so let's say a to the power 0. This is just equals to 1, right? Okay, so base, so meaning here the base was a to the power answer is equals to what is in the middle. Okay, so meaning this, when I write it in log form, it will be log, the base is a, okay, what is in the middle is 1 is equals to 0. So whenever I have log of any number and then what comes there is 1, then this is just 0. Okay, because when I take it to exponential, it will just be a 0, a power 0, which is definitely equals to 1, regardless, okay, regardless of the value of this a. So a can be any number. So take note of this law. We're going to be using it in the questions. Okay, 6. So guys, if you have any questions, please ask. Okay, so the other one is a very interesting law. Okay, it's a very interesting law, and they like putting it in the questions. So they're saying that if I have log, if I have a raised to power log, which has a base a, okay, of whatever I have here, maybe x. This here is just the same as x, okay? So if I have a, and then I have a log which has a base a, this part here cancels out, okay? It just becomes x like that, okay? Just becomes x like that. So whenever you see this situation, we're just going to be saying this is the same as x. So mathematicians are difficult people, are very difficult people. So what was wrong with just writing x? And then they start coming up with these things here. So always know, okay? So if you have a and then log to the same base as what you have here, okay? The answer will just be whatever is there. Okay, so meaning if I have 10, log base 10 of, let's say, k. Here the answer is just k, okay? Because this part here is going to cancel out according to this property. Okay, and then what other properties have I not talked about? Okay, the other property is that if I have log base A, okay, log base A, um, log base A of B, which is equals to log base A of C, okay, then B and C should be equal. So I'm sure you even did this as a proof in your class, okay? So you have to know how to prove that. All right, so those are the rules that we are actually going to be playing around with, okay? And then the other one is when changing the base, okay? When changing the base from one base to the other one, you use this rule. Okay, so if, for example, I have log base A, B, okay? And then I want to change this base A here to another base, let's say base C, okay? So what I'm going to do is that I'm going to write log of the new base C, okay? And then this one, which is the odd base, okay, it becomes the bigger letter in front like that, okay? And then I'll say divided by log base C, and then I'll put B there like that. Okay, so know this rule here when you're changing base from one base to the other. So you can be given log 3, okay, log 3, maybe 5, and then they tell you change this to base 2. So when you change this to base 2, it will be log of the new base 2, and then you get what was the base here, you put it in front here, divided by log base 2, then put this 5 in front like this. So this expression here and what we have there, they're actually the same. Okay, but they're just representing them in different ways. Okay, so these are the rules that you need to know when you're dealing with logs and exponents. Okay, I think for exponents, we also talked about the indices, right? We did some rules there for the exponents. Okay. All right, so now that we know these rules, let's try to practice. Okay, let's try to apply them in questions and then see if we are able to solve. So if you have any questions, okay, on what I've explained, please ask. Okay. Otherwise, I'll continue to look at some exam questions. Okay. So the first one is this one that you can see here. So they're saying convert the following exponential equations into logarithmic form. So I have 6 to the power 3 is equals to 216. So how do I convert from exponential, okay, to logarithmic form? So remember, we said we had if I have log base A, B is equals to X, we said this here is the same as what? It's the same as A to the power X and then is equals to B. This is what we said. Okay, we said we are using the mnemonic key, BAM. Base to the power answer is equals to what is in the middle. Base power answer equals what is in the middle. Okay, so it means here, this one here, it's just the base. And this one is the answer. This one, it is what is in the middle. Okay, so you see that if you know the representation there, it will be very simple to convert. So now you write your log now. Log base 6, okay? And then what are we putting here? We put what is in the middle, which is 216 is equals to the answer, which is 3. Okay, so we have converted the first one from the exponential to the base. Okay, so any questions there? Okay, what about B? Okay, so it's the same situation, very simple. So this one is the base. This one is our answer. This one here is our middle value. Okay, so meaning if I convert it to a log, it will just be log 4. Okay, then what is in the middle is 1024 is equals to the answer, which is 5. Okay, let's do one more, and then I can leave the other ones for your practice. So C, we have 7 to the power 3, 3, 4, 3. So we use the same concept. So this is the base here. This is the answer, and this is the middle part. So if we turn this into a log, just be log base 7 Okay. And then what is in the middle is 3, 4, 3. This is just equals to the what? The answer like that. Okay, so any questions so far? Any questions there? Okay, so I'm very sure, okay, you can be able to convert this one, and this one. You can convert them to the log form. Okay, so now let's do the inverse. Okay, let's start converting from the log form to the exponential form. So that's what we are going to solve next here. Okay, so where is that now? Did I put those questions? Okay, I put these questions 2 times. Okay, so here I was supposed to put those questions. So let me get them. Okay, so those questions convert these ones here. So I didn't get these ones. Okay, so let's convert some. So A, we have log base 1 over 7, 49 is equals to minus 2. Okay, so we want to convert this to an exponential form. So we know that this here is our base, this here, it is our middle, okay, and this one is our answer. So when you convert, okay, we use our BAM. Very important. Okay, so base to the power answer. My base is just 1 over 7 to the power answer, okay, is equals to 49. And this is true because here, this one, okay, since I have a negative power, remember when we are talking about exponents, okay, or indices, we said if I have a to the power a to the power minus x, this is the same as 1 over a to the power x, right? So it means this one here is just going to be 1 divided by this same thing, but to the power positive 2 now. Okay, so what would this give us? To give us 1 divided by this power goes to the 1, it still remains 1. 7 power 2, it's 49. And then now you change this to a multiplication. So you have 1 multiplied by 49 over 1, which will just give me what? 49. Which was my answer here, this one here. Okay, so this is true. So let's try to convert C. I've skipped B. So C is log base 9. 2, 4, 3 is equals to 5 over 2. So I want to convert this. Okay, so as usual, base, middle, answer. Okay, BAM, we follow it. Base to the power answer is equals to what is in the middle. Done. Okay, so any questions there? Okay, any complications on converting, okay, from the log form to the exponential or the exponential to the log form? Any problems there?
I have a question.
Yes, please. Yes, please. Ask the question.
So I like make this explain here, like I didn't understand.
Where should I explain again?
I'm starting from log base 7 and then okay, just everything.
Okay, so the first question, that's what you're saying. This one here.
Yes, please.
Okay, so there we were converting from the log form that we've been given to the exponential. Okay, so remember we said the general log is just log base AB is equals to x. So if I convert this to exponential, we said we're going to say base to the power answer is equals to what is in the mid. So we are moving like this. Okay, so the base here is a to the power answer is equals to what is in the mid. So this is our exponential form from our log form. So now here, look at this. We have log to the power 1 over 7. So the 1 over 7 here is our base. And then what is in the middle is 49. which is equals to the answer, which is what? Minus 2. So following this rule here, okay, we're going to say this is our base. So base 1 over 7 to the power answer, which is minus 2, is equals to what is in the middle, which is 49. That's how we found the answer. And then the other part, I was just trying to show how this is equals to 49. Okay, so have you gotten it now? How to convert there?
Yes, I have. Thanks so much.
All right. All right. So uh, let's look at the other concepts now, okay, where we are using some properties of logs. Okay, because these ones, I'm very sure you can convert this one because we are just converting from one form to the other. So now let's look at these questions here where we are solving them without using a calculator, but we are solving. Okay, it's like we are prophets now. So let's look at this one here. So A, we have log base 7, 343. Okay, so how can we find the answer there without using the calculator? Anyone was at a suggestion? Okay, just using those properties that we talked about earlier. How can we find the answer there without using a calculator? Okay, so here we're going to use two rules. Okay, so remember the rule that we said if I have log base a b to the power n, this here was the same as n log a b, right? We can drop this power in front like that. And then the other rule that we had was the one that said that if I have log a base a, we said this here is just the same as what? 1. That's what we said. So these two properties of logs are the ones that we are going to be using here. Okay. So what we want to do is just write this number here as 7 power something. Okay. So that we can drop the power and then we are going to remain with the log 7, which is just 1. Okay. So this is equals to log base 7. But we notice that 343 is actually 7 to the power 3. Okay. So by this row here, this one here, I can drop the 3 in front. So I'm going to have 3 log 7. Okay. And then by this row, if my base and the number that is in the middle is the same, then it's just 1. So this will just be 3, 1. Okay. So the answer there on A is just 3. That's the answer there. Okay. Okay. So if I have any questions, please ask. Otherwise, we'll look at B. Let's look at B. Okay, so B, we have log base 2 of 256. Okay, so we're just using those same laws that we wrote down here. These same ones here. These are the ones that we're going to be using. Okay, log A, it's just 1. So what we want to do here is make this guy here be 2 to the power something. Okay, so 256 expressed as a 2 to the power something. What do you think it is? Okay, so you should be thinking in those ways. Okay, so this is just algebra, the first topic that we did. So 2 to the power 8. Okay, you can try it on your calculator. It's going to give you 256. So this will just be log base 2 of 2 to the power 8. So now by this property, I can drop the 8. So I have 8 log 2, 2. But log 2, 2 is just 1. So here the answer is just what? 8. Okay, so that's what we do there. Okay, let's look at C. So we're still using the same property. So C, look at what we have now. We have log of base 3 over 8. and then 27 over 512. So here, we just want to express this as a 3 over 8 power something. Because the base there is 3 over 8. So I want to express this as 3 over 8 power something. So 27 in terms of these 3 here. 27 is the same as what? Okay, so 27 is the same as 3 to the power 3. So that's how I'm going to write this 27 here. And then what is 512? Okay, what is 512? 512 is the same as 8 to the power 3. Okay, so that's the same as 8 to the power 3. So here I'm going to write log of 3 over 8. Remember here I said 512 is the same as 8 to the power 3. So in the brackets, I'm going to have 27. I'll write it in this form. So to be 3 to the power 3 over 512. I'll write it in this form. So to be 8 to the power 3 like this. And then I see that I have a common power there. Okay, so I can factorize it outside the brackets. So inside I only have 3 over 8 to the power 3. Okay, and then from there, what do we see? We see that we can drop this 3 in front, right? Because it's the power now. So it will be 3 log 3 over 8 and then 3 over 8. So this will just be, remember this is just 1. So this will just be 3. So the answer there is what? 3. Okay, so let's do D and E, and then the other ones, you can try them out. Then you are done learning about properties of logs. Okay, so let's try D. So D, we have log 11, 1 over 121. So now, remember that we can actually write a number, a fraction, as a number raised to a negative power. So we said a to the power negative x is the same as 1 over a to the power positive x, right? So this is what I can see here. So I want first of all to express this as a log base 11, and then I write 121 to the power minus 1. Okay, because 121 to the power minus 1 is the same as 1 over 121. And then now I look at the number that I have in the bracket here. Can I express that number as 11 to the power something? Okay, turns out that the 121 is the same as 11 to the power 2. And then I have minus 1 outside. So I can say this is log 11. And then I say 11 to the power minus 2. When I multiply this 2 and this. So what I have is that the minus 2 will drop. And then I have log 11, 11. So this will just be what? This is 1. So the answer there is minus 2. Okay, so any questions there? Okay, what about this E here? It looks interesting because there are points there. Let's try to solve E. We see what we're going to get. So E, we have log of 0.1 and then 0.001. Okay, so here we can try first of all to turn these things into fractions. Okay, so what is 0.1? 0.1, since there's only one decimal place, it's just 1 over 10. Okay, so 10, it means there's one decimal place, and I'm just putting 1 0. What about this one? So 0.001 is the same as 1 over, I'll write 1, and then I'll count the number of decimal places that I have. So this is 1, 2, 3. So I'll add 1, 2, 3. So I've turned it into a fraction. Okay, so you see how beautiful math is. So this will now be log 1 over 10, and then I have 1 over 1000 like that. But I can express this 1 over 1000 as 1 over 10 to the power something. So we know that if I say 10 times 10 times 10, this is going to give me a 1000, which is just 10 to the power 3, right? Okay, so meaning that I can write this as log 1 over 10, and then this one here inside, I'll write it as 1 over 10, and then to the power 3. Okay, so meaning the 3 will drop. So I have 3 log 1 over 10 and then 1 over 10. This will give me a 1. So I only win with what? 3 as my answer. Okay, so any questions there? Any questions there? Okay, so let's look at one last question. Okay, let's look at one last question here. And then for the other types of questions that come on logs, those ones I already did videos. So I'm just going to share after this class. So G, look at G. Does not have any log there. I mean, does not have any base. Okay, so what does it mean when something does not have any base? Okay, so when something does not have any base, simply means its base is 10. So this one, without any base here, okay, it's the same as log base 10 and then 1000. So this would be log base 10. The 1000 is 10 to the power 3. The 3 drops in front. So I have 3 log base 10, 10. This is 1. So I only mean with what? 3. Okay, so that's basically how you can use those two laws in order for you to solve such type of questions where you're calculating without using the calculator. Okay, so any questions there? Okay. All right. So if there are no questions, I think we can end here. So we've learned the properties and how to use them. And then for further questions on this, I'll share the videos because I already created videos for the other questions here. So you can see that we only did question 5, 3, question 5, 6, and 7 in this tutorial sheet. Uh, this question 8, okay, we are solving these equations using those laws that we are discussing. Okay, so I'm going to share a video where I was solving this one. Okay, so if you find any challenges in understanding whatever I'll be doing in those videos, please feel free to text me. Okay, and then I'll be happy to explain. So the question 8, we solved. Question 9, okay. Sketching, we did. Question 11, this one here. Okay, so these are exponential equations. We also did question 12. Okay, so all the questions here I explained, and that was the end of the tutorial sheet there. So, okay, so if you have any questions on the videos that I'm going to share on the other questions, please feel free to reach out to me. Okay, so do you have any other questions before I end the class? Okay, so those who would like to register with us, okay, we actually been doing free classes for 2 weeks now. Okay, so very soon we'll just start concentrating on those who are actually subscribed and our members. Okay, so our lessons are 150 per course per month. So once you register, you're going to access our website. Okay, so on our website, we have tutorial sheets there. Okay, we have lessons on each topic, and you can learn anytime, anywhere. Okay, even in your blankets, you can learn. And also for those who have Android phones, okay, I must emphasize. So if you have an Android phone, we have a mobile app. Okay, so on the mobile app, you'll be required, you'll be allowed to download the videos. So when you go at school where there's Wi-Fi, you can download as many videos as you want that are on our website, uh, which you can also access on the app. And then once you go back to your room or your boarding house, wherever, okay, you can even turn off the data and then you can start watching the videos offline. Okay. So for those who have Android phones, inbox me your email. I add you, okay, so that you'll be able to install our mobile app and then you can access the videos there. Okay. So the videos for tutorial sheet 1, full solutions, they're already there on the website. Okay, as soon as tutorial sheet 2 is 2, I'm also going to do videos of that. I'm going to upload full solutions on the website. Okay, so you can actually use our website to to learn at your own time. You can use our mobile app to learn at your own time. All right. So thank you so much and have a blessed night.